today, Watt's Law. We are going to show you how to figure out 4 watts and the importance of watts. Here's the importance of watts. Watts is actually power. So, let me put it down here. Watts is how much power something is drawing. And that becomes very important because I need to know how much power something is drawing, because that's going to give me an idea of what size wire I need to run to the circuit and what size breaker I need to run to the circuit. So we're going to give you some things you're going to need to know. P is power, and that is watts. So in our formula, P is going to be watts. In our formula, I is going to be my amperage, so that's amps. And then E is going to be my voltage. And for today, all our voltages are going to be rated at 120 volts. And the reason is 120 volts is because all your outlets in your house, the calculation they give us for that is 120 volts. We draw this as a wheel. So my watts, which was P, is equal to my amperage times my voltage. So if I could find if I know 2 of the 3 things, I could always find the third. So suppose I know something is drawing 5 amps at 120 volts. I'm trying to find P, so all I would do is I would cover the P. That's what I'm trying to find, and I times E. So 5 times 120, I should know that off my head, is going to equal 600. So P would equal 600. Okay? So I'm trying to find P, so I cover it. I knew I and I knew E. Now we could do it as trying to find E, and I know P is 1,000. So P equals 1,000. Let's say I equals 10. And I am trying to find E. So, if I'm trying to find E, I cover E, it's P divided by I, P divided by I, and that is going to equal 100. Maybe I'm trying to find I'm trying to find the amperage, and I know the voltage was 120, and I knew the watts was 2400. So trying to find I, so it is P divided by E, so 2400 divided by 120, so the amperage is going to be 20 amps. And that's how we use the wheel for finding watts. Another reason we use watts is to see how much I could load a circuit to. And when I mean loading a circuit to, I have multiple devices on a circuit. And say, as an example, if you have your mother, your sister, and they're in the bathroom and they keep tripping the bathroom outlet. This might be an idea why. They're using a blow dryer. So let's say the blow dryer setting is 1500 watts. And they also have a curling iron. And they have that plugged in. And that is also 1500 watts. So right now at that outlet, I add those together, they're drawing a total of 3,000 watts at that outlet. Well, remember, I said we're going to use 120 volts for that, so it would be, to find my amps, the 3000 divided by 120, and that is going to tell me how many amps that circuit is actually drawing. So 3000 divide that by 120 is going to be 25 amps. Well, your bathroom circuits, they're run on a 12 wire on a 20 amp breaker. So if that circuit could only handle 20 amps, and when I'm using the blow jar and the curling iron at the same time, that's drawing 25, that is 5 amps too many. It's going to heat up the wire and it is going to trip the breaker. So that's another reason that we need to know the watts of a circuit. The watts will help us determine what the amperage is, and it's going to help us determine how big of a circuit we need and the size of the wire. That's it. Hope I kept it as least boring as possible.